All right. Hello, everyone. Welcome back. In today's lecture, we are going to be talking about your computer data and how that works, and as well as how it is stored for you. So, many of you probably have phones, or I hope all of you do. And for my iPhone users, you probably know the issue of storage. So, I'm sure you're probably wondering how your phone or your computer stores the things you're placing on it. Because I'm sure if you are an iPhone user, you're always sick of saying or seeing that storage message that you have to buy more storage. So, we're going to basically be talking about what data you have and how you store it on your technology devices, more specifically your computer. So, what exactly is data? So just think of data as the information your computer is using and processing to run any of the tasks you're doing. So we went over your hardware, we went over your software. Your software contains data, and your hardware, your CPU, uses that data to figure out what it needs to do. So there's various different types of data. So you have text, you have numbers, images, audios, and video. That's all sorts of data that your computer and your phone stores. So how does your computer see the data? So what we're looking at right now, we see a bunch of letters. Your computer does not understand any of it. It's like a foreign language to it. So although your computer displays it, it actually doesn't know what it is. So your computer only understands two numbers, and that's 0 and 1. And that's what we know as binary. So although your keyboard has all of those different symbols, characters, letters on it, your computer only understands two of them. And we're going to be pretty much discussing how and why that is. So everything on your computer is actually built from binary. So every time you type a letter, it basically is converted to binary for your computer to understand. Every time you save a photo, every time you save a document, it is in binary so your computer can understand it. So let's deep dive into binary. So, as I just mentioned, binary is basically a number system that only has 0 and 1. And that is how your computer represents everything on it. That's how all of the data on your computer is represented. So each digit is what we call a bit, which is short for binary digit. So all of your computer and all of its data consist of zeros and ones. So just picture that, just like that picture on the screen. That's basically what happens in your computer. That's how your computer looks. We are seeing how your computer looks through the GUI, but your computer internally actually looks like that icon on your screen. So, how do they use it? So, your computer has various circuits within it that turn on and off. So, based on the number 0 or 1, it would be on. If it's 1, it would be off if it's 0. And that's how it figures out what to do. It has its own language. It knows what to do based on the number of zeros and ones it has, but it's basically how your computer understands how to operate. So that is why binary is so important. Your computer is operating off of binary. So, as I mentioned, your computer has to convert whatever you're doing to binary. So in the case of text, so that's going to be all of your characters on your keyboard. They are given a numeric code, which we call ASCII. So that ASCII is what we say ASCII. And basically, you have an ASCII code that is used to convert that character or letter, number, symbol into binary. And so it's just think of it as a code. So you're going to have a number for a letter, and then that letter basically will provide the number to the computer for it to understand what letter that is. So all of these characters on the screen are zeros and ones. And as you can imagine, it's a lot of zeros and ones just for this one screen alone. So going back to ASCII, it stands for the American Standard Code for Information Interchange. That's what it stands for. But we just call it ASCII. And it's basically just a system that was created to assign a number to the characters that you see on your keyboard so that it can be processed using binary. So if you look at this little chart here, is an example of what that looks like as well as binary. So you see the letter A is equal to the ASCII code 65. However, the lowercase a is equal to 97. So yes, they are the same letter, but they are two different characters because one's uppercase and one's lowercase. So they do have two different numbers. Um, and that means their binary value is different. So if you look at the two, their binary value is not the same. So basically, every time you type a letter, your computer sees one of those numbers in the binary column. So all of those zeros and ones every single time you press your keyboard. So here is a overall shot of just the binary codes alone, not ASCII, but the binary codes of each letter. So you see they're all different. And I'm sure this is probably making your eyes hurt, and I completely understand. But this is exactly why your computer does not show this to us. Because imagine if you were to see this on your end. You probably would never touch a computer. So that is why looking into computers and computer science is cool, because you get to understand exactly what's going on, although you have no idea that it's really going on. So this is what you're doing when you're typing. When you're texting, it's the same thing. So this is what's going on internally. You just do not see it. So your CPU is processing these binary codes. Your CPU gets delivered, for example, that very first character A. If it gets a 01000001, then it knows that's A. And each binary code is made up of 8 bits. So you just keep that in mind. There's 8 numbers in each character for it to understand. So same with images. Although you see your image is made up of pixels. And so those pixels then map out to different color values. So what color is that pixel? You know, so if you have a picture of a black car, but it's blue outside, the sky is blue, that means your picture might have, black and blue in it. So each pixel that is made up in that picture has a color value. And each pixel is made up of 24 bits. So that's 8 bits per color. And each color or each pixel is going to have a combination of colors in it. So when those colors occur, those colors are going to have a value that's going to be stored as binary. So we'll take a look at that. So how does RGB work? That's how you get your color value. So RGB basically stands for red, green, and blue. So each color that your computer understands is going to be made up of a mixture of R, G, and B to create the color that you see on your screen. And each one of these, R, G, and B, will have a value from 0 to 255. So, for example, if you want to have a bright red, then your pixels would be RGB value of R, which we have 255. You would have no value for G or B because it's basically saying your standard red. Now, let's say you want to make it darker red, then you might add on some values to the G, or you might add on some values to the B to make it a little darker. But regardless of that, that RGB value then translates to your binary for your computer to understand. based on the 3 values. So if you see it in the binary, you have 3 separate number values separated by the spaces. And for 255, it is all ones. So that's basically saying that the top level of the RGB value you can have is all 1. And for your zeros, obviously it's going to be all zeros. Now it's going to change based on the value that you're giving it, of course. So from 0 to 255, that would change, but this is what it is presented as. So that's a little glimpse into how your computer values or sees your images, your colors on your computer screen. So here's another screenshot of that, just giving you an idea of the different values. So you see for the green one that green is at 255. For the blue, the B value is at 255. Yellow is made up of the red and the green. So you see both of those are maxed out. And down for your tealish color, we have the green and the blue at 255 as well. And each of their binary codes is different. So again, as you modify your colors and as you make more detailed colors or different ranges of colors, your binary code would be different. So here is an example of a color chart. And it actually has what we call your RGB values and your hex values. So it's basically 2 different ways you can tell your computer what color you want. The RGB value is going to be the one at the bottom. So for example, if you spot the aqua, then you see aqua is a RGB value of 0255255. And in the parentheses, it does always stay consistent. So your R is always first, your G is always second, and your B is always going to be last. So although it does not say RGB here, it does go in order. So for gray, it's basically saying your R, G, and B value are all 128. So that's basically how your computer represents your colors that it sees through these various values. So now that we pretty much understand the basic of at least how your images and your text look as binary code, we're going to slow it down to understand a little bit more terminology into it. So a bit is one binary digit, okay? So that would be just one singular 0 or 1. And you would have 8 bits, which make up your 1 byte or your 1 binary code. So if you remember from the previous slides when we covered the A and the uppercase A and the lowercase a, remember I said it was made up of 8 characters. So that would be 1 bit. So 1 bit equals every symbol or every character of your code, except the digits are different. So the more bits you have, the more data it is. So obviously, if you click A and T, that would double the amount of bits that show up to your computer, and so on and so forth. So remember that you have 8 bits for each character, which is 1 byte. So 1 byte equals 8 bits, and 8 bits equals 1 byte. So here's a visual display of that. You basically would have zeros or ones in that red box that you see, but all of those together pretty much make up 1 byte. So your byte has various measure sizes. So if you've seen MB or megabytes, that's basically what that is. And if you see megabits or MBPS, that would be it as well. So your storage components also use bytes. So terabytes, gigabytes, all of those are using bytes. It's just based on how many bytes are being used. So here's an example of that, your various data sizes. So like we mentioned, 1 character would be a bit. Let's say you're writing email, That would be if you ever see KB. So you can look on certain things that you do, and sometimes they will tell you the storage components or how much, especially if you go to your files on your computer, you'll see this. So if you see megabits, that means you have over 1,000,000 bytes. If you have gigabytes, so for my phone users, all of your phones, for the most part, are running on gigabytes. So um, each gigabyte is 1,000,000 bytes. So some of you probably have 256 or 128 byte phones. So that's basically 128 billion bytes for you to store information on your phone, and so on and so forth. So that would be your gigabytes. And your terabytes, this is generally for my gamers. Then you know that your game console generally starts at a terabyte. And obviously, that terabyte is still not enough to store your games. So you might have various hard drive that you connect with various terabytes on them to store your stuff. So these are your data sizes. Okay, so just keep that in mind. All right, so first we're going to have our first keyword of the day. First keyword of the day is going to be ASCII. 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 That's our first keyword of the day. All right, let's keep going. All right, so let's get into that data storage types. So we just covered how your data translates as far as your binary goes. And now we're going to talk about how it's stored. So you have primary storage, you have secondary storage, and you have cloud storage. Okay, so your primary storage is going to be your RAM. So that's going to be the one that is directly on your computer. But with your RAM, it's basically temporary. Your RAM is only used while your computer is on. So when your computer turns off, your RAM does not store whatever you were doing. So that is what RAM is. So in the case that you want it to stay there, that would be your secondary storage, which is permanent. So that would be like, your secondary storage devices, your USBs, stuff of that nature. And then you have your cloud storage, which is, relatively new in the last decade, where you can store stuff in the cloud. So that would be your Google Drives. That would be your Microsoft 365 or OneDrive. That would be iCloud. Just storing stuff over servers in the internet. So just to give you some way to understand how they all play a hand or how they all work, your RAM is like a desk, right? So when you go to school or when you go to a class, you sit at the desk, but you would not necessarily leave your stuff on the desk once you leave. Once you leave, you usually clear your desk and then you come back and put the stuff back on the desk. So that's how a RAM works. When you leave, it leaves. When you come back, you place the information back onto the RAM. So that's how the RAM equals a desk. Now, in the case of your secondary storage, think of that as a filing cabinet. That's stuff you're saving. So when you put the stuff into the filing cabinet, it's going to stay there until you go there to grab it out of the filing cabinet. Do you have to go grab it back out of the filing cabinet? No, you can leave it in there forever. However, it is there if you need it. Where in the case of the RAM, you would not necessarily always bring the same stuff back to the desk every single time. And your cloud, just think of that as a warehouse. Basically a bigger version of a filing cabinet. It just has endless rows of it. So that's how basically each of these break down. So deep diving into them to understand them a little bit more. As I said, your primary storage, your RAM, is just temporary. It's just using whatever memory it has at that moment to pretty much run while your computer is running. So this is going to be fast. This is going to be, your data is going to disappear when it powers off. So this is what happens when you're running programs or you're multitasking and things of that nature. So that is what your RAM is. Your RAM is fast. And when I say RAM, that actually stands for random access memory. Most people just know it as RAM instead of memorizing random access memory. But it basically is just a temporary memory. And that your data is going to disappear when you turn your power off or when you close your computer laptop. And then it may restart when you open it. Now, for your secondary, that's permanent. So that's what you're storing your stuff in, your C drive, your desktop, your downloads. That would be permanent storage that's inside of your device. It is slow, so when you go to access those files, it takes a while for it to boot up. It takes a while for it to load whatever it is, and it is slow, but it stays for a long time. So this is the data that stays when you power off your system. So saving all your files, apps, even your operating system is stored in secondary. Then lastly, you have your cloud storage, and that is data that's stored over, remote servers via the internet, and it just makes it accessible from anywhere. And it basically is where your backups live. So, when you get a new phone, you have to transfer your data from one phone to the other. And this would be the case of cloud storage nowadays. If you have an iPhone, then you would know when you transfer your phone, it basically accesses whatever's in your backups and puts it on your new phone. So, cloud storage is very important nowadays, and it is connected to everything you do. For example, if you all did not know, your school accounts are always going to be connected to your cloud. So Microsoft has this cloud called OneDrive, and it's typically free, so you can access that through your student email and store all your files in the cloud. And that way, if you don't have storage on your computer, then you can put it in the cloud. And then you also have backup in case your computer breaks for whatever reason. So I would highly recommend, using that in case your computer breaks or something happens and you don't have access to your files. All right. So yes, we're saying cloud storage, but your cloud storage is not actually floating in a cloud. It's actually stored in data centers all around the world. So, no, it is not actually above us. It's actually somewhere in the server room or a data center, and it's stored there. So, data centers, yes, they do actually look like this picture. They're a bunch of servers. All of these servers are holding data, and they pretty much have the data that you're using. They store it, they process it, and they give it back to you. So your websites, apps, videos, files, everything you can think of is going to be stored in a server. And if you're using the cloud, that basically stores your data through one of these servers in various locations all around the world. So how exactly does it work? Like I said, you would have a cloud service storage. So Google Drive, iCloud, or OneDrive on Microsoft. So you're going to send a file to the data center. The file is going to be stored there. It's going to be backed up, so it basically has a copy, and it's going to be made available to you from anywhere you are. So you can access that data from this laptop, the next laptop, the computer library. The library computer. You can access it from a tablet. You can access it from a phone. It basically makes your data accessible from anywhere. So, for example, if you want to work on an assignment and you put the assignment in the cloud and you're out and about and you want to work on your assignment from your phone, then you can access it through your phone from the cloud. So the cloud is very beneficial. So if you don't use the cloud now, I would highly recommend it. It will make your life a lot simpler, and it automatically saves your work as well. So generally, if you're working on it and something happens, your computer blanks out, it does save it. However, if you're doing that same thing on your computer directly, most of the time it will not automatically save, so your stuff will be wiped. So sometimes you can think of your cloud utilities and apps as a bonus because it will pretty much save your life in some cases. But basically, once your file is stored into the cloud storage, um, you basically have those files copied to a CDN or a content delivery network for faster access. But those would be your popular files. So, for example, if there's a specific file that you access all the time, like constantly, then it will be added to the CDN or the content delivery network so you can get it quicker. And the CDN will pop up again in the future. So before we move on, your second keyword of the day is going to be cloud. So second keyword is cloud. So the CDN, as we just mentioned, your CDN is just a network of servers that are around the world, and they're delivering your web content. So your websites that you go to most often live on a CDN. And it basically will map out where it needs to be stored based on which data center is the closest to you to store it, so that it will get to you quicker and it loads faster. So it basically just makes it a lot more reliable for things to come to you quickly. So, for example, one website that would probably be on your CDN would be Google or Microsoft Edge, because you probably access one of those every single day and you need to get to it very quickly. So that would be an example of how a CDN case would be used. Whereas, for example, like a website like let's see, website you wouldn't necessarily go to, like a cooking website, a cooking recipe website. You wouldn't necessarily go to a cooking website every day, but you might go to it. So that cooking website would not necessarily be on a CDN for you, but it would just be in a server or a cloud server somewhere stored and its access. And let's say you start going to that cooking website every day. Then your computer would then basically place it into the CDN, and then that way it's easily accessible to you in the future. So that is how that works. So sometimes if you go to a website and it takes a little bit to load, that could be the issue, or sometimes it could be your internet, who knows. But either way, sometimes that could be the issue for you as well. So that is where your CDNs come into play. And why does storage matter? Your storage is going to impact your performance, your speed, and everything that goes on. So you need storage to save your stuff and run your programs, because if you had no storage, you couldn't have any programs. And that is why it's important. So everything is pretty much relying on storage for your computer. If you have no computer, storage, then your computer basically has nothing to show you or run, because your operating system alone needs some sort of storage to run. So let's take a look at a real life example. So I know all of you use YouTube. So we're going to look at a YouTube, for example. So YouTube is basically a giant digital library. So imagine going into a library that's massive, and just think about the number of videos in YouTube, right? This has to be the biggest library in the world. So think of those videos as books that are placed on a shelf, right? So for you all, your favorite YouTuber would be placed on your front shelf, which is your CDN. Or the ones that you see when you go to your home page, those will be your popular videos, and those will be the ones that are directly on your CDN. Whereas the ones that you have to go search for, like the ones I create, like you wouldn't necessarily be watching that all the time, but they are on a shelf somewhere, and those are just living in a data center. So for the ones that aren't necessarily viewed a lot, those are in archives or in the data center somewhere. So they do exist, they can be found, they can be viewed. It just takes a little bit more time to access them. But the popular videos are going to be basically in the front on the CDN, so basically in the front of the library. So that's basically how it works. So think of it in that way. All right, before we jump into how our websites are going to work, your last code is binary. Binary is your last code. All right, and your keyword. I mean, binary is the keyword. All right, so let's look at how your websites work because you're using a website as we speak and you use websites every day. So when you go visit a website, in this case, you would be, let's say, going to YouTube, right? You're requesting to go to the CDN server that's closest to you. And it's basically going to say, okay, you want to access YouTube. Here's all the information you need for YouTube to show up on your screen. And it's basically going to send your content for that screen you need or for that video you need back to you, to your device. And if the content isn't in the CDN, so it's going to look in your CDN first to see if it's easily accessible. If it's not, then it's going to find it from whatever data center server it's currently at. It's going to grab it and then it's going to store it in a CDN close to you for next time to make the process simpler. So the very first time you visit a website, it's not necessarily going to be on your CDN. But if you visit it consistently, then it will then be on your CDN. So that's basically what's happening in the background. And just like I said, think of it like that last terminology or we did with the digital library real life example. So I know that was a lot, but we basically just covered how your data is created and stored on your computer. So just remember, all your stuff in your computer is all binary, 0 and 1, and they are converted through some sort of system depending on the data type. So, images, text, audio, and video are all converted to binary in different ways. It just depends on the type. You also have different types of storage. So you could have the ones that are directly inside of your hardware. You could have the ones that are temporary storage or secondary storage through USBs or SD cards. And then you also have your cloud storage as well. And data representation. Remember that ASCII is for text, RGB is for color, and file formats are for structure. So your directories or your file folders. And all of these, again, go back to your zeros and your ones. All right. So, thank you all for listening to this lecture. Make sure you remember those keywords, and I will see you in the next one.